Be right back. Welcome to Backyard Plinking. My name is Charles. I'll be your host as we go through and explore everything BB and pellet related, from air pistols to air rifles, targets, and ammo. So, alright, Scooter, what's the deal with the spoon and the pigeon? Well, it took me a little bit to figure out exactly how to do this so I can at least be fair. A lot of math. I'll try to do this quick so you don't get bored. I've shown you a lot of brake barrels here as of late. Like everything else, everything has a reason and a purpose. So, .177 brake barrel. There's been some springers, gas pistons, vortex, nitro piston, this, that, the other, all by different manufacturers. They're all the same caliber. What else do they have in common? They advertise 1200 feet per second, 1100, 1250 with alloy pellets. They all make one claim, 1000 feet per second with lead pellets. Now we have a constant. This one's better than this one. The vortex hits harder than the nitro piston. The nitro piston, now we have something to go by, okay? Because of their claim of 1000 feet per second. So the first thing you have to do is go through and figure out, well, how many foot-pounds of energy come out, right? There are some calculators out there that you can go through and just plug stuff in, but this right here is basically the formula. So to give you an example, the one I just shot was the Crosman F4. I used a 7.4 grain. So we know, because it's 1000 feet per second, we know the weight grain. We do the math. The 450, 240 is always a constant number. That's what we come up with. 16.4 foot-pounds of energy. Granted, that is at the muzzle. That is not over there. So I had to do some other math and figure out bullet coefficient and gravity and drag. And so what I come up with was the fact that at 1000 feet per second, with a 7.4 grain, .177 projectile, there should be enough foot-pounds of energy to, now this thing is, it was tight, should be enough to strike this so-called stainless steel spoon, make an indention, transfer enough energy through to break the clay pigeon. Big deal, it's a clay pigeon. Well, that's true. Center doesn't take much. Where these rings are, this is what I'm aiming for. It takes relatively a foot-pound of energy to crack them on the ridges. We have another constant. We have one here and one there. Now we can find out if a vortex piston is better than a nitro piston. We can find out if a springer is actually hits hard enough to keep up with the gas pistons. Which one does better? Sorry it took me so long on the math, but it's a good trigger finger, but something with a calculator is just, it doesn't pan out very well. So, we went through all of that. That was the F4 you just saw. Obviously, it had no problem transferring enough energy to break through here. And we'll tell you this much. This large serving spoon that I have, after about 5 rounds on it, we're going to have to get another spoon. It stresses the metal too much, and instead of transferring the energy, it vibrates. So give me just a second. Let me put another pigeon on here. We still got a couple of licks we can do on this, and we are going to try the Daisy 1100 WS Springer. Alright, we got another clay pigeon taped to our spoons. Why didn't you use rubber bands? Well, it has to be attached in more than just them 2 places. The reason I taped it to it is to make sure that there's good contact and there's no vibration, there's no gaps or anything like that, because what we want is for it to hit, transfer all the energy through the metal and then into the clay pigeon, because we know exactly how much it takes to break one of the ridges on a clay pigeon. If it's loose or if it's not on there, out the window. So the first one we did was the F4 crossbow. This one, the Daisy 1101 WS, 7.4 grain destroyers. This one is a true Springer in every sense of the word. It's just a large spring inside of a cylinder, releases its energy. I'll be right back. That's where it hit. Or what the F4 looked like. I mean, it took out the whole bottom section. This thing kind of destroyed it. Now, two, three, four, five. That's about it for this spoon. And it's not really stainless steel. Self-tapping screw went through there. But the density worked out right as far as the math went. This is just to give you an idea about how I'm going to go through with some of this stuff. Now, I do have a better attachment form that I'm going to do, but it's going to take me a little while to kind of get them all set up. I just wanted to put this out there and kind of give you guys an idea, because what I want to know is, who do you think's going to win out of the .177 caliber stuff? I mean, you know, you had to go back through the videos and look, but I mean, we had to farm it. We had the 1101, the one from Hatson, the Vortex Edge, not the 25, but the .177 caliber, the F4. It's been several of them. Which one do you think is going to come out on top? Springers, Vortex, nitro piston? I don't know. You know me, I don't really have a dog in this fight. As long as it does what it's supposed to, I'm happy. Anyway, post what you think's gonna win. We'll see. Might have to make a contest at it. Till next time, my name is Charles. This has been Backyard Plinking.